Let's start the new topic, Newton's universal law of gravitation. We will start by understanding the statement of this law. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So this is also one kind of mathematical relation. You have to write down the statement if it is asked, then each and every word should be as it is. And now, such kind of arrangement we will see by consider two particles in the universe. So here I have considered two particles, particle 1 and 2, having mass m1 and m2. Which are at the position with respect to origin. Their position vectors are r1 and r2 respectively. So, the force which is existing on this body is directly proportional to the product of their masses. So here if I am writing that force existing on particle 1 by particle 2 is directly proportional to m1 into m2 divided by the distance between them which they have considered over here r12 square. So this is the first relation, and you know it very well that if I remove this proportionality and want to find out the magnitude of the force, then I have to put some proportionality constant, and here the proportionality constant which I am putting is capital G. And remember, this capital G is the gravitational constant. And now instead of R12, generally I am writing the result as small r. And so this is equation number 2. And here the value of G, or first of all, what is G? That we will discuss. So G is the universal constant of gravitation. And why it is called universal? Because if you look at the statement of this particular law, Then in the statement it is written every body in the universe. So this value, or we can say the value of G, is same at all the place of the universe, and the value of G was determined by Cavendish experiment, and the value of G comes out to be 6.67 into 10 to power minus 11 Newton into meter square per kilogram square. So this is the value of G, and the dimensional formula for capital G is given by m minus 1 L3 T minus 2. So this is the dimensional formula for gravitational constant, and this you can determine from this unit. So this is depending on you. Now here if you consider the distance between two particles 1 and 2, so it is given in this way: r2 vector minus r1 vector, and the unit vector for this I can determine by dividing the vector by its magnitude. So this particular is having the value r2 minus r1 divided by mod r12, and now this mod r12 I am giving as simple r. So these two are equal. Therefore r12 vector. So it is clear that force on particle 1 by particle 2. So the force is exerting on this by this second particle. It is equal to Gm1 m2 divided by r square into, now here only vector you are putting, then it is necessary that you should fix some kind of unit vector also. Then this is your equation number 3. Now if you want to find out the force exerted on particle 2 by particle 1, then it is very easy to determine, but it is having the negative sign, and this negative sign is coming from the vector notation used over here. Because you have to put r21 vector, but instead of r21, I had put r12 vector, and that's why this negative sign comes, and it is also in the opposite direction to the F12. So Gm1 m2, if I remove the negative sign, then I have to change this unit vector notation. And you can see from equation 3 and equation 4 that F12 is equal to minus F21. And so I am giving you the directions of F12 and F21. Suppose here the particles are there, particle 1 and particle 2, and here is the origin O. With respect to the positions, I can write down r1 vector and r2 vector. Now, the force exerted on particle 2 by particle 1 is given in this direction. So this is F2, one vector, and the force exerted on particle 1 by particle 2 is given in this way. So this is F1, 2. Now, this is only for two particles, but suppose for n particles you extend this theory, or we can extend the value of force, then the force due to such extended object is equal to the vector sum of the forces exerted on it by all the point masses. Now what is this point mass? And these point masses will be in extended object. Now see, here is the particle 1, and particle 1 is having mass m1 and it is denoted by a point drawing on it. So this point having mass m1 is called point masses. Thus, the force on particle is given by F1, and the force exerted on particle 1 by particle 2, similarly by particle 3, by particle 4, plus so and so extend till what are the particles or what are the number of particles. It is equal to gm1 m2 divided by r12 square plus gm1 m3 divided by r13 square plus gm1 m4 divided by r14 square, and I can extend up to n particles. In the same way, we can find out the total force on an extended object by the another extended object, and we can take the two observations mainly. From this theory, and in this particular case I am giving you the arrangement of three particles. So here is the first particle which is at point P, this is second, and this is 3, and the force or the direction of force you can clearly see. So the first observation which I should make from this, the gravitational force means G by a hollow spherical shell of uniform density See, it is having the uniform density. So equal mass is distributed on equal area. on a particle outside the cell is equal to the force which can be obtained by considering the entire mass of the shell as concentrated on its center O. So by mathematically this observation can be written by the force which is exerting on particle 1, so that forces are only F12 and F13. So no other forces are acting on this particular concept, and the second observation is the force on a particle at any point inside a hollow spherical shell of uniform density is 0. So no force is acting inside the particle from the outsider particle. So this is one advantages of Kepler's laws observation or Newton's laws of gravitation observation. Now we will see some analysis over this universal constant, and we will actually see the examples related to the above discussed theories.